On a hill far away stood an old rugged cross, and
Hey creators,
emblem
here's this
of
month's creator
pain and day. What's all this?
roundup. We've launched a new account status page in the YouTube Studio mobile app for all creators globally. Account status provides an at a glance view of your channel's health, like copyright alerts, community guideline strikes, and monetization eligibility into one hub. You'll see clear indicators for any issues that need your attention, along with actionable steps to help you resolve them quickly and keep your channel in good standing. To get started, tap your profile picture in the top right corner of the Studio mobile app and select Account Status. We've rolled out live countdown stickers. Countdowns are a fun way to get your viewers hyped for a specific moment in your live or to build anticipation for a special reveal. To add one, tap the stickers icon, then select Countdown. Tap to choose a color and start typing to add a title.
I don't use
Next,
mobile.
tap the sticker to your imagination takes center stage with our latest update to Shorts Remix. To get started, tap the remix icon, then select Reimagine. Type your idea, or if you're stuck and need a starting point, swipe to select a suggestion. We're introducing Unique Reach, a metric that estimates the total unique people who saw your video or we've added conversation history in Ask Studio, now available globally. We're expanding gifts and jewels to even more countries, including Brazil, Mexico, the Philippines, Malaysia, Singapore, Vietnam, Hong Kong, and 16 additional countries across Latin America. Gifts are a fun and interactive way for your viewers to express appreciation and react in real time during your live
I
stream.
don't have any
Viewers
viewers.
purchase.
Sharp. Okay. So I cherish that old rugged cross. Okay, I don't need to be watching this here. True that last I laid down. Oh, well, why did I close my Chrome? Oh, well, it's not really Chrome I need Godot. So, yesterday we did some work. I grew some understanding, especially after I woke up from my short nap today. I didn't get as much sleep as I wanted to, but as they used to say, at all, I be wish. So, I just realized some certain things. Like I've really been taking why the heck is the color like this? A like wrong approach to trying to solve some of these problems. Like I've not actually taught myself and sat down to think like what is addition, what is subtraction, what is multiplication, what is division of a number do. I've just been trying to guess which one going to use. So when I thought to myself, and I was able to like I've read it like a couple of times before, but like it didn't stick to me that if I want to shift something, let's say I want to shift UV coordinate, or I want to shift the starting point of a wave or something like that, I'll use addition or subtraction to shift depending on the direction I want to shift, whether left or right. If I want to if I want to scale something, I'll use multiplication to scale it or division to scale it. So if I want to normalize something, I will scale it by the magnitude of the thing. So those are, if I say I will divide it by the magnitude of this stuff. So let's say I want to like map out my keyboard. Like let's say I get using Godot input get function to get my mouse location in the screen. So I get my mouse location and I want to map it to my UV axis. I will just divide my mouse location by the I'll divide my mouse location by the screen resolution to make it to be a number between 0 and 1. So then it is normalized and I can now use it in my ASIC system to maybe like swap things. So I was thinking I could use something like that to do something like maybe Minesweeper or something like that. But yesterday, we had a task that I decided not to do. That is that in Prime Spiral. I don't remember the other name for it, but the Prime Spiral. So I'm going to do the Prime Spiral now, or I'm going to attempt it now. So I'm going to create a new scene. But before then, I don't know why this scene is this color. This wasn't the color I was using. So let me see if I can play it and just test it. Reset grid. Okay. So why was it that color? I have zero idea. But like, it's not really what's pressing right now. I'm going to come back to this stuff and analyze it. Like I said before, like some of the optimization technique and the rest is just way too early for me to start trying to wrap my head around it. Like using multiple viewports, the using multiple shader scripts to interact with each other and the rest. I just need to get the shader logic down to my head. So I'm going to just save and close. I'm going to close this. We're just going to create a 2D scene. I'm going to add to the scene. I'm going to add the canvas item or canvas layer. I'm going to create. I'm going to under the canvas layer add a color rect. Then I'm going to screen this color rect. Rect. So I'm going to attach a shader script to its material. Attach new shader material. I'm going to create a new shader script, shader new script, and I'm going to call this prime spiral. Now I know that I drew a grid yesterday, but I don't know. I won't be using a grid today, so no need to redraw it. I just need to recreate. I'll recreate the prime number stuff. So not only am I getting better, so I don't only get better at shader programming, but at programming in general. So in my fragments and stuff, the first thing want to do is that I want to shift UV to the center. So I'm going to create a float. No, I'm going to create a vector two, and I'm going to call this UV centered, or let's just make it UV cent, and I'm going to make it equal to. So what I'm going to do is I'm going to multiply. Oh no, not multiply. I'm going to subtract 0.5 from UV center. So I'm going to subtract. Okay, I'm going to do UV minus vec2, and I'm going to subtract 0.5 from UV. So that should then centralize my UV. So now I can use UV center instead of using UV and just shift UV center however I want to shift the stuff. Then what am I going to do now? So what I'm to do, I'm trying to do prime spiral. So what we want to do is that for um each prime number, I don't know, how am I going to create a dot? How would I create a dot? Gosh. Okay, no. You know what I'm going to do? I'm going to create a box. I'm going to subdivide my screen into 1,000 box. I don't know whether we can calculate 1,000 prime number. You know what? 1,000 box is going to be quite ambitious. So we can always scale it up to 1,000. But for now, I'm going to divide my screen into 100 box. So the first thing I'm going to do is I'm going to change the center position of UV to center. Then I'm going to multiply that vec 2. So this is UV scaled. UV UV just dash CS. So this is UV centered and scaled. And I'm going to just do UV. I'm going to do UV centered multiplied by 100. So this should make the whole place, so the bottom from negative from 0 to 50, and the top from negative the top from negative 0 from negative from 0 to negative 50, and the bottom from 0 to 50. Left, same thing. So that's what I expect this to do. But okay, this should be a float. All right. So now that that is done, I have my axis. Now I can simply, just to be assured that we are starting from the center. If I were to draw a gradient now, say color is equals to um, UV dot is equals to vec4, and I'll say UV CS um, comma UVCS dot X. Then do the same thing, UVCX, UV. I shouldn't have made this capital letter and small letter dot Y. And then I'm going to put 1.0 comma 1.0. I'm just going to close this. So we should have a gradient originating from the center. Okay, why is it not a gradient? Hey, wait. First and foremost, that's not going to work because UVCS is actually not is larger than this thing. So I just use UV center. UV center. The UVCS is larger than the values that color should be taking. UV center. So if I come back and look at this, it's not really. You know what? Let's simplify this stuff. So let's just do UVX. I'm just gonna make this 1.0. Let's observe. Each it's not showing me the I don't know. No, okay. I know that I have shifted my UV, but I think is one thing to shift the UV, is another thing to actually another thing to actually use it. So obviously I we are off to a good start, but I am not there yet. So let's just ask Gemini how to use it, because like he's wanting to shift the center, like he's wanting to have a variable that's actually pointing at where you want. So another thing to say, okay, you want to paint a gradient from that center spiraling outward. So I need to learn how to use it. I can make it now, but I don't yet know how to use it. So I need to make myself comfortable using it, because to solve this spiral, the prime spiral, like start this prime spiral from the center, we need to understand how to paint from the center and shift it. So I'm just going to paste here, and I'm going to let me remove this. I'm going to say I wanted the gradients to originates from the center. Okay, to make the gradient direction in the center, you need to calculate the distance from the center of the UV rather than just using the raw center coordinates. Okay. Uh, so I create my UV center, then I create a I get the distance from the center. Ah, this is more complex than I thought. Optional map it to. Wait, this one is center is what? That'll be 0.5. The square root of 0.5 square. Let me just punch my calculator. 0.5 square plus 0.5 square square root of answer 0.7. Why? What's special about 0.7? Because this distance value is 0.7, then it's not doing 0.7 times 2. That's root 2 or 1 point this thing. Then we're minusing 1 from it. Why? 1 minus answer. That's minus 0. Or let's say 0 point. I don't get. Ah, shit. Let them copy this to our text editor. Okay, it said UV center 0.5, comma 0.5. At the exact center, the distance is 0. Next to the edge, the distance is 0.5. So, um, 1.0 minus distance times 20. Since distance goes from 0.0 center to 0.5 edge, multiplying it by 0.2 stretches it to a 0.0 to 0.1 to 1 point. So I mean one range. I don't know if maybe my calculation was wrong. Let's look at it. I'm still very dull, and I had help for today that I was beginning to understand. Ah, shit. Okay. So let's look at the gradient it made. Not quite what I wanted, but okay. Obviously, we don't want to use vector here. Let's remove this because having a black gradient is just the most boring thing you can have. 1.0, 1 point 1.0 comma 0.0. Okay, all right. So, we are ensuring that the gradient value is no more than 0.0 and 1.0 to prevent negative color. So, if the value is in the negative axis side, if the value is too negative, we just use 0. If the value is positive, we use 1. Ah, shit. Wait, we calculate the distance from the center. We calculate the distance from the center. Okay, first thing we do is okay, yes, we can't use the center to actually the normal UV to actually plot it because regardless of what the UV dot center, while it shifts the center that where UV dot center is now technically 0. is now actually in the center. When we want to start painting, this color function doesn't care about that. This color function is still going to start painting from where it's painting to where it's painting. And having assigning the value of UV center is just going to say that we're going to use only half of what we are supposed to use, even if we were to like no, what was my previous code? Even if we were to what do you call it now? Even if we were to passing UV dot center, what we are just doing, and this UV dot center is a value of zero this thing. What we're just doing basically is just telling it to paint the normal UV coordinate using half the color and some invalid colors, which is going to ignore those invalid color and use half the color. So in order to get it to actually paint the top points, the color we need it to paint the top point, we need to now compare that top point's color to the color of the center and say, okay, how far is this point from the center? So that it can actually experience that shift. I don't know if I'm getting it. How far is it from the center so you can actually experience that shift? So that's it. I think I've got it. So yeah, we need to get the length of the stuff. So we need to have a variable called yeah, we'll do that gradient. Let's try and write that function without looking at it so that I can know whether I picked it. We have a vec. No, now we have a float, a floating point number. This floating point number is called gradient, and this gradient, that's not spell gradient, if I'm not mistaken. Right? Yep. So um, this gradient is the length of um the UV center. So it's the length of UV center. So that's the basically the magnitude of every all the points that we're going to be plotting. And but we're not just going to plot the length. Like for my calculation, if I'm not mistaken, from my calculation, the length actually is going to be 1 minus this because the length at the center is where we want the value to be 1. You get at the center we want the value to be 1, and at the center is the square root of 0 square plus 0 square. So at the center, when we do 1 minus that length, it's going to be that when we go to any of the direction, as long as any of the direction, it doesn't matter, as long as we are going outward from the center, any direction we go towards, um, we keep on the value of the gradient, we keep on decreasing, decreasing, and decreasing until we get to the edge. Okay, so that's for the that. Then we're just going to come here and put gradient here. I don't know whether this gradient value is within the limits. Okay, yeah. So that's that. Now, but my calculation tells me that at our peak points, that's at our edges, the square root of 0.5, because that's the range of the highest points is now 0.5. The square root of 0.5 plus 0.5 square is 0.7. So the maximum length is actually 0.7, 0.071, not actually 0. Not actually 1. So meaning that we are not actually getting the full spectrum, and we can tell by, let's say, if we remove these other colors, so that we just have the gradient, comma, let's make the gradient vector vec 3 of the gradient. If we just have a vector of the gradient, you see that, okay, it's getting all true, like it's feeding all true. So you mean to tell me that the distance between here, the center, and the extreme edge, okay, let me ask here, because that's just one of the math that I'm not comfortable with, because I feel like we are stopping at somewhere like around 0 point TB. Okay. The square roots, the square root of 0.0.5 square plus 0.5 square is equal to 0.7, is equal to 0.707. We are not using the full color spectrum that we, because see now they are doing 1 minus, okay, what's this distance? Yes now, 1 minus, okay, they are multiplying by 2, but when you multiply by 2 it becomes too great. I feel like this their own is wrong, safe. Why would this be correct? Control A, Control C. The value of those corners dropped to 0.02. It never reaches 0. So you lose out on the full contrast rate. To fix it, you need to scale the distance so that the farthest point you care about is actually 0.0. Clamp to the corner. Option true 0 at the corner. If you want the gradient to stretch all the way to the corner, so the very tip of the square are pure black, you will need to multiply the distance by 1 over 0.7. Okay, so we need to multiply the distance by the normalized, or we need to, no, what am I saying? Multiply the distance by the normalized. What nonsense is coming out of my mouth? Okay, so but why? Oh yeah, yeah. We need to normalize the to be in the range of the of actually the this math does not sit well with me. But I feel why it's correct, but it does not sit well with me. Maybe when I sleep on it and wake up, it will be I will have more clarity on it. But for now, I'm just going to Control A and paste it and look at it. This is not what I want. Let's try this one. I don't know why it's getting rid of my skilled value. I will just have to type it out myself. Control A, Control V. Nope, I haven't preferred the previous one. Actually, is correct? It's correct. It's correct. No, it's not correct. Oh yeah, it's correct. The extreme tip will not turn black. Yeah, yeah. All right. So we're also going to do our let's just create it now. Vec delete vec so and we're going to say UVCS that's centered and scaled. I'm going to make it equals to UV centered multiplied by UV divided by UV by 100. Okay, we have point 0. So now we need to create a function and that says is prime. So we have so we say float is prime. Um we are going to return 0.1. So we can say we return 0.1 if it's prime, return return let's say 0.1, we're going to return 1.0. We're going to return 1.0 if the number is prime. If the number is not prime, we're going to return 0. So first and foremost, 1 is not prime. So if num and we're just going to come here and here is going to take in a float of a float called num. Is that how you define it there? Okay, yes. Then let's open a bracket here, close this bracket, open a parenthesis, then we're going to return 0. If num equals 1 or one, I think 1 is the only number that I want to return 0 for. Then we're also going to come because I don't think I'm going to make my loop check for 2. Should I make my loop check for 2? Yeah, let's make my loop check for 2. Let's add 2. If num equals 2. So we're going to uh, my bad. We're going to return 1. Now, okay, let's make this an else if. Um, point 0. Then else we're going to perform. We're going to go through this for loop. Now we're going to put the return statement in the for loop. Control X. I couldn't write for loop that day. I don't know whether I'll be able to do it today. Okay. This thing should automatically be changing my. Okay. So now I'm going to say for. I'm going to create an integer I, or yeah, I think int will do. For I equals 3. Mm, I okay. Let's also before we even do this run this loop, we're going to check else if um num is no the mode of num. How do you define mode again? Num command 2.0 is equal is not equals to that's a it does not have any remainder, so it's not equals to no it's equals to 0. We're not just going to run the follow part. So if the mode of the like if the number is divisible by 2, then there's no need to run the for loop because the number is even. So so we're just going to return 1 point sorry 0.0 because the number is not prime. Then we're going to come back here and we're going to say I is less than or equal to the square root of num. Then lastly, I plus 2. Chiama, chiama, eh. Invalid argument. Okay, let's just make it a float to save ourselves the issue. Float. Personally, I don't even know why int exists. Like, if you can use a float for int, like, why have a float in line 14? Expected a comma. Okay, you did not close the last one. Return one. We did not just return one. We first check. So we run the loop and we check. So our condition for breaking out of the loop is now this is a number that we know is not even and is not our odd previous number. So we say I is equals to 3. Then we do the I is less than or equals to the square root of number. So that's the number of iteration we're going to run. So we're not going to say if I if the mod of I comma uh, sorry of none comma I is equals to 0. I am messing this function up. Is equals to 0, then okay 0, 0.0. Return 0, 0.0. Else now we can't say else return, so we have to first close the for loop. So like if the for loop ran without returning this thing, then we return for the control X. Okay. The for loop has to encapsulate the if statement. Delete. Then we're going to just control V here and we're going to put in the for loop. Close the else statement. So I think this is a good is prime function. Listen, control C is my is prime function correct. It might not sound, but we do not work in GIS shader. In standard programming languages like Python, the loop is fairly fine. However, GPU shader has strict hardware constraints that makes your current implementation incompatible. Here's why it will fail, followed by how to fix it. Why it fails: dynamic loops are forbidden. GPU achieve massive spread by executing the same instruction across thousands of pixels simultaneously. Because of this loop condition, because of this, the loop condition must be knowledgeable by the compiler time. Constant expression. Your loop condition is I is less than the square root of number. Depends on the pixel input value, which changes per pixel. This will throw the compiler error to Godot. The condition must be a constant. Okay. Variable initialization. In your loop for float, Godot shader language requires you to declare a variable type, but the JLS for loop strictly expects an integer. Okay. Uh, Float point precision. The mod function float point number can introduce tiny precision error. Test mod number equals 0 will often return false even when the number is perfectly divisible, because the result might actually be 0.0000 point. Okay. How to fix this? Make a prime checker that works on the fragment shader. You have to force the loop to run a fixed maximum number of time using a constant integer, and use a break statement when you reach a dynamic limit. Okay, it's prime, it takes a number, then it says, okay, the first thing it does is it rounds the number to the closest integer. Yeah, that's good to do. Then if the number is less than 1, it returns 0. Less than or equals to 1. If the number is equals to 2, it returns 1, yes. If the number is divisible by 2, it returns 0. That's okay. Then calculate the integer square root. Okay, if you first do the square root outside, then you put limits. Then you come here. Why do we have a max check? Okay. No, the max check is not 100. The max check is actually, okay. Oh yeah, parallelism, so that it can know the, okay. I don't know why it's so foolish. It saw code under my prime is prime function. Why did it delete those codes? Or it thinks I'm stupid? Okay, so this should work as my prime function. So this was a good attempt, but doesn't work because the loop has to know its ending point and its beginning point. And also, my leg hurts. Um, int hash check equals to 100. I think that's a constant. Yeah, constant integer. I might not do 6 hours streaming today. I might go to bed early. I asked my mother. I don't know. So we have a store that checks if the number is prime and attribute it. So now we can call is prime from our code and now draw the spiral. So basically what we're going to do is that we're going to use our center coordinates to do it. And we're going to use this distance. This distance is going to be a very big help for us. So in a way, I want to kind of visually see what this distance is going to plot. No, this gradient method is not going to work because for the spiral, let me write out the spiral, the prime spiral. The way they do it is that um let's just Google that AI chat, but let's Google it. Prime Ulam spiral, Ulam spiral. Maybe word core. Ulam spiral. The Ulam spiral or prime spiral is a graphical depiction of a set of prime number devised by mathematician whatever in 1963 and popularized by blah 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 blah. I really do not care. I want to just know what it is. Ulam Gala, strike me, construction. Okay, and this is what we need. So we have one. Yeah, we have one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the spiral is technically increasing on every iteration as it's going. So on our first count, we're going to on our first count, we're going to count 1, 2. On our second count, we're going to count 2, 3. So we're going to count two numbers. We're going to count one number, then turn in the first count, one number and turn in the second count. Then on our third count, we're going to count one number, two number. We're going to count them 1, 2. Then we're going to turn 1, 2. We're going to turn. On our third, we're going to count 1, 2, 3. We're going to turn. We're going to count 1, 2, 3. We're going to turn. So for every two steps we take, we will increase the turn by 1. For every two step we take, we increase the turn by 1 to get a spiral. So we want a way to actually index it. So like first and foremost, we have to the distance between ourself. Yeah, we can use our normal length function. Look, it's let's think. Let's just think how you going to translate this. Now our length function, we can use our length function to say, okay, um, let's say we write, but we need to have a way to give direction. Okay, let's create a shifting function, or let's try and map out this shifting function. We might not use it, but let's just map it out. Void shift. So so basically we want to shift so how do we shift? Normally if we're using our normal UV, let's assume normal UV actually knows that center is center and everything. Normally UV we would have done UV dots, caps of UV dots, UV dot X. Okay, wait, we shift on we okay, wait, no, it's not even that we take two steps, then we add. We shift on the X. We shift on the X by one step. we shift on the y by 1 step. Then we go again, we shift on the x by 2 step. We shift on the y by 2 step. We shift on the x by 3 step. We shift on the y by 3 step. So I think that's even a better way to interpret this question. So we're going to uvx plus, or let's just say uv. Let's assume uv is a let's say uvx plus num. We're just going to, I'm just sketching that. Let me just comment it so that it does not keep on giving me this red line. This red line is annoying me. So we're going to say uvx plus num, then uvy plus plus num. Then num plus 1. I think this is how we are going to make the spiral. We're going to say uvx plus num, then uvy plus num. And we're going to add 1 to the number. Then we're going to repeat. Then we're just going to go over and over and over again. That will give us that's going to actually create a spiral of holding all our numbers, not all our prime, but all our numbers. So we're going to hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we're going to just so I think we need to create boxes. We need to create grids. Uh, Grid is something we have created in the past before. We created a grid in the past by doing this. Let's say, so now that we have this our center, we just come here and say um, floats grid, and we're going to set it equal to the max of the step of the mark of the step of it's going to be a double step though. It's a step of comma step. Then we're going to have uv. We're going to have the frac of uv center comma 0.09. if if I'm not mistaken, I think it's something like this. Then we're going to also do the fract. Basically, we're trying to say that we return 1 if and only if one of these values are 1. So that's either uv center is 1 comma 0.09. Now, I might be mistaken. I might need to actually flip these values. Sorry. Control X, comma, Control V. let me cancel that second call. So, um, oh yeah. Sorry. Dot x dot y. So we're going to return one for if any of these conditions are true. Then we're going to come here. We're going to just mix, and we're going to draw. We're just going to draw out, comma. Um, let's have a vec. Let's have a maybe blue line. I know this is going to look like disgusting, but like then we're going to just put grid here to use it to select. So if the value is I'm okay, something's not right yet, but we'll sort it out. We'll sort it out. Okay. Uh Wait, let me look at how the marks work because I and also how the step work because I think I'm flipping the function. Godot shader. Built-in functions. Okay, let's see. We used the mix. Where is mix? Where is frac? Okay, look at frac. Frac returns. Where is mix? Okay. Mix linear interpolation between A and B by C. This does not give me the details I need. Okay, yeah, 8 times 1. So if C is 0, the output is A. If C is 1, the output is B. And if grid is 1, okay, so this line of code is correct. That's fine. RGB. The line is not really the color I wanted it to be. I wanted the line to be blue. Okay. Um. So the error is coming from here. And obviously, a simple fix for this error could just be for me to use actual UV. UV. But the reason why using actual UV is doesn't solve all the questions because right now we're going to draw plot UV. UV dot y. Then what we can I simply say is no, um UV multiplied by 100.0 multiplied by 100. I have way more line that I should be having. Okay, let's flip. Let's return back to where we were before. No, 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 not that far back. 0.0. Um, so instead of doing it, I think let me flip the arrangement of step control. Okay, let's read the step documentation. Control F step. Okay, so step if B is less than A returns 0, else it returns 1. Okay, the first value is A, the second value is B. So basically we're taking the fractional side. Oh, when shall I see Jesus and reign with him? We want this value to return 1 where we have a grid. So if now of my soul, the push the bonnet was never concealed. What shall I render to you, Lord? I will bow down and worship your name. You are the Lord. You are the Lord. You are my God. You are the eyes I used to sleep. You are the kiss. Okay, let's not use fract. Let's not use fract. Let's use something else. Maybe render to you, Lord. I will bow down and worship your name. I think fract is the only thing I can use. You are the most high. 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 You are the most high God. Why is me zooming in changing how many boxes is drawing? The heck? Let's ask Gemini. I'm not just proud of myself at all. That I can't draw a grid today. Okay, so what did it change? So I'm correct now. What's the difference between what I wrote and what it wrote? I was expect I was expecting 100 subdivision, but what I got is way more. And if I zoom, it changes. What the heck? Which function is f with? Mm. You think you are learning something, then all of a sudden the system wakes up and tells you, "Oh, that was for yesterday. Today we're working differently." Like the heck? Let me look at the code I wrote that. Oh God, I want to go and clean it up yesterday. Okay, this was our former prime. What's the difference? Okay, maybe it's because I have my fract control X. Let's say I have a like F U, and let's have it here vector F U V. Wait, another thing I'm doing. This is a way larger scale. Wait, let's scale down a little bit. So it's just the scale that made it go crazy. That it was zooming out and it was changing if you zoom in or zoom out. Okay, it's actually fine. It's just okay. So it was actually fine when I drew it. It's just that it's trying to optimize by leaving out Such a massive. I was like, have I become stupid? Something I did yesterday, I can't redo again today. So the optimization I did not suggested was that um, that to make the grid stay permanently stable and crisp and clean regardless of the zoom level, you shouldn't use a fixed multiplier like 100 mixed with raw step. Instead, you need to use derivative screen width to calculate how big a pixel is in screen space and smooth the line out. Go crazy. Mm. It so confidently told me, okay, what is it? So confidently told me nonsense. Okay, this is beautiful. But if drawing this was this much work, now imagine calculating the prime for each of these in each cycle of a GPU. I don't think we can do that. I don't think we should do that. I think we should calculate it, read out using the GPU, load the data into an image, and read from the image to perform whatever operation we want to perform on the screen. I do not think we should find the prime number up obtain 1000 error and 1000, finding 1000 error. That's just what I think. We shouldn't be finding such large value. But I'm going to try it either ways to just have a feel. You get. Okay, let me read my snake another code. I can try use a mod. Okay, now um let's play with it. Let's see whether it will work. I can come here and say um because basically what we're doing is that no, that will require me to use an if statement. Oh, wait, so something more is happening. It's not just repeat. We add to x, we add to y, then we subtract. We technically, we technically increase the value we're adding to x and the value we're adding to y, but then we're subtracting. Then we add one to number. Then we subtract from um x. We subtract from we subtract from uv x. Do the same from uv y. Then we repeat. So right here now, we take as our input, we say num. The first step is 2. So the first thing we want to do is that we want to add to the number. Oh, sorry. Let's just change the number. So the first number is 2. So the first thing we want to do, because if I come back here, the first step is 1, 2. No, the first step is 1. So we'll perform the operation before we add. So we say, what variable are we using now? Yeah, let's use UV center. No, it will be upside down. It will be upside down if we subtract first, because up, if I'm not mistaken, even though we shifted the graph downward, down going down is still going positive, and going up is still going negative. I don't know if you get what I'm trying to say. Because normally before, up is in UV 0, 0. Let me just bring it out the graph so that we can see it. UV coordinates. So it's up in U. Wait. Oh, I'm wrong. Wait, let me see. UV coordinates in Godot. So I will not be image. Why can't I just find an image like the one I saw of that one? AI. Top corner is what? The UV coordinate map in top left corner is 0, 0. Like I said before, 0, 0, 0. So if we were to shift the center to the middle, it does not change the fact that, let's say, let's open, okay, I cannot show you guys. It doesn't change the fact, but I can show myself that um in the graph or whatever, let's say you have a graph, the bottom part, the bottom left, and if I say bottom, the bottom right is the positive axis. So yes, moving 1 plus to go to the left is correct. But then if we want the spiral to go the way the spiral went in this place, we move 1 plus, then we move then we move minus to come here to go up. Then we move minus again to go this way. Then we move plus to go down, minus again. So we're going to have to flip the sign. So we're going to say UV plus, then we're going to say, then we're going to have to do minus. Then we're going to come here. We're going to say plus one. Then we're going to do subtract, yes. Then we're going to add. Then we're going to repeat. So that's how it moves. So I could use a if statement, but the truth is I'm not feeling confident that that's the right way to do it. So I'm just going to Control C, give this to AI. We're cheating a lot today, but I think I've written the logic, but I'm not just confident that we should do that with an if statement. Because you're working with shaders, you have to translate this sequentially to a repeat logic. Sometimes GPU can execute parallel or do cleaning. To help translate this to GLS for you, you could share the kind of visual effect of mathematics pattern you're trying. Let me just show you my code. Control A, Control C, Control V. Monicule. So where is the shifting code? Okay. Absolute. This function takes a 2D grid x and y and returns in. I don't understand what I'm reading here. Yeah, we can't actually use a constant to do that thing. Int x and int y. Why are we calling it in? Get Olam's number, cell x, cell y. And cell x and cell y is UV centered law. Okay, we're flowing, so you just get the center of all the boundaries. Okay, so when we get the cell x and cell y, then what they are saying is the the absolute value of x, y max get layer, then total number contained in inner layer. Why do it like this? Like, why disregard the logic I just came up with to do it like this? Hmm. Okay, now I don't feel fulfilled. I felt like I should have actually have solved this myself. Now I lack the fulfillment. I didn't do it the way I was even planning on doing it. So like I do not feel like I've even learned. I need to stop cheating with AI. You know what? I still have a chance to try my method and fail with my method. So that's what I'm going to do. I'm going to do exactly that. I'm going to try my method. So my plan was to actually call my function at this point. So I'll call is prime here. So I'll say so basically what my plan was that this function is not a void, it's a float, and it returns either one or zero. We could have just have made it a bool and return a boolean variable, sure. But because we want to use it in a mixed statement, that's why I'm returning this thing. So is a float. What we're going to call the float. Let's see. Here's a good place to call it. Um, we're just going to say vec. Sorry, I'm going to say is no. I'm going to say shift. And we're going to call is prime. We're going to give the value of is prime. No, shift doesn't need the value of is prime. Is prime that needs the value of shift. Is prime needs the value of shift because we are going to shift regardless of whether the number is prime or is not prime. And is prime. So what we're not actually going to be returning one, we're going to be returning the number count. So this one is going to take in a UV. This is going to take in a cell, a cell number. Let's just take inspiration from the cell number. It's going to be a float, but it's going to be top float, just as we did here in our previous code. Here, just as we did here, where not this one. Um, when I get older, no, no, this is not the one I want. So, okay, I think this is it. Okay, yeah, just as we did here, the what we did was we mapped the coordinates seamlessly to 0 to 9 by doing this. Control C. So basically, what we did is we floor. Hey, give me freedom, take me higher. Singing forever young. get older, how will you be stronger? They call me freedom. I can do the FME. FME. Oh, oh, oh. This is the most ugly code I've seen in my life. But no worry, I'll give it to you to rewrite it. Okay. So we're saying whatever may be the value of UV, so we're getting the this thing. I'm going to come here now and return. I'm going to return cell because uh, its prime needs cell to work. I don't think there's any need to nest these two stuff. We're going to call shift. We're going to call this prime. Okay, yeah, its prime needs cells to work. That means we should define cell outside here. Control X. That's a cell. Let's call it cell. Just define it here. Then we're going to make these two functions independent of themselves. Yes, these two functions take cell as input cell, but they do different things with it. Color, we're going to paint the cell, paint in the pattern of cell. Oh, my body, my head. I have to figure this out. Like, even though I even end up writing the code that the AI generated, like, I need to get there, like, understand why I did it, so that, like, try what I'm thinking should be, understand that what I'm thinking is wrong before I can do what it's me to do. So, cells are already a number. That's not what we want. We don't want cell to be a number for obvious reasons. We want, okay. So, is prime is taking in cell, like the cell number, but shift is not taking in cell number. Shift is taking in UV. Yes. We're going to convert this to a vector. We're taking a vector because, like I said before, we have to translate the logic. How do you return to? Oh, my bad. Okay, so we're going to return a vector that's going to have cell.x and cell.y after we have performed operation on that cell.x and cell.y. So what are the operations we're going to perform on cell.x? We're going to do cell.x. We're going to create an we're going to create an integer. Or let's create a float. Float. I'm going to assign it the value of one very terrible code. But well, I'm going to assign the value of one. I'm going to say cell.x. Now, this is not ideal, but we're going to do it. What am I trying to achieve by shifting like this? Because it's one thing to write out this stuff, but like it's another thing to say, um, okay, we are going to be returning as we are shifting, but like, what are we actually trying to achieve by doing that nonsense? Because if we shift it, no matter the complexity of the algorithm we used to shift, oh no, the complexity of the algorithm we used to shift it matters a lot. It matters a lot. It matters a lot. Let's shift it first. You know what? I can even just come to this return function, this return place, and write the whole code. But no, say for I equals to 0, I okay. No, this is wrong. This is wrong. Why this is wrong is that very forward up statement. Oh my god. We'll use the previous one you gave me. Um, let's go into doing other things. We have done maths enough. Maths is boring. Okay, so let's save. Let's do something else. So, as usual, we're going to create a. Now we're going to come here. We're going to attach a script, and we're going to say, I want to do Minesweeper. Minesweeper. So we're going to make this a tool that we can run in the editor. So we're going to be using the process function. Then we're going to say get global mass position. Also, we're doing get events, get inputs. Okay, let's just ask. And we don't need all this. So I'm going to save as I'm going to reload projects. And hopefully if I click will print to the console. Oh, I forgot to add. Oh god, we'll have to reload the project again. Oh sorry. No, it's already now. This would have been enough to do Minesweeper, but we want to also like do glue, like box glue. If um if we hover, so we also need to do get mouse position in the process delta. Get global return to go relative to the canvas layer that contains this node. So what we're going to do is this is now we have this. So basically what we're going to do is that we're going to come to shader, we're going to texture, I mean material, new shader material, new shader, my sweep create. Then I'm going to come here. I'm going to create a uniform vec to call it mouse pause. Then come back here. Then from here we're going to say on ready uh, So basically, the format, I don't know, I don't really remember the format so well, but basically the format is trying to say that we're going to get the material, we're going to get the shader parameter, we're going to get this mouse position, and we're going to set it to the global mouse position. Then we're also going to um, have a boolean, a bool, so uniform bool mouse clicked. I think this should be enough to do my Minesweeper. Control A, Control C. So come here. Che che coole. Help me. So we see Urama, I day on my 10 toes. When this love is share, baby. You know I love you, but I'm always on the girl. How you put me in the mood. I know you want them to. And I carry shoulder down for you, bro. Oh my for me, pa. We don't break my spine. I love. Carry shoulder down for you, Joe. I'm all alive. Oh my, ring it on. No one come out for mine. No one come out for mine. Never seen a girl so fine like in my life. I must go. Like I know that I hear they blow my mind. They give me peace. Okay, so as you can see, the GPU, if you can see it, the mouse coordinate is moving. But we are not getting a click event because the click event is not in. So in the GPU code, we have to clamp this mouse position. So we have to clamp it. Clamp, clamp, mouse, pause. How do we even write clamp back in the day? Back in the day, they would narrate me. Uh, Control clamp. Okay. So in the clamp, we are clamping vector A vector. Okay, wait. Clamp C minus A, B minus A. Okay. Clamp X between min and max. So minimum value, maximum value X. Okay. Yeah, so we are clamping mouse position between 0, comma 1. And we're going to save this as mouse pulse. This is already a normalized value, so it's already UV. And this is a vec. So mouse pulse. Sorry. Um mouse mouse. Let's say that mouse. So we are clamping the value because we are seeing that it's getting to the negative, which is not good. So if we come here now and we go like this, I'm expecting go like this. I'm expecting it to just give us a value of 1 in the x and continue giving us whatever value for our y's. Same thing as here, whatever value for our y's. We go like this, that the y now becomes negative. It will give us 0 for our y, then whatever value of our x is, and like that. So what we can do now is, also if we click, we are also capturing that. So why are we normalizing? Wait, if I remember the code, we are normalizing the. Let's forget about that. Um, let's see what the ARM code does. before we write our code. I can have my cushy. I can have my Louis Vuitton country. Okay, don't talk about because even okay, that's beautiful. I can have my Gucci, Gucci. Uh, I made you, I made you. Well, I look good in my Versace dress, and I'm harder when my morning hair's a mess. So now what I'm going to do is that I want to create a grid system, have the box glow. Then if we click it, we are going to the box is going to change color. If it's a safe box, it will change color to green. If it's a dangerous box, it will change color to red. But the initial color is going to be um initial color is going to be what you call it now. The box initial color is going to be blue. So that's my plan. Gucci Gucci Louis Vuitton. But even with nothing, uh, great I made you look. I made you look. And I look good in my Versace dress. Take it off. Money as a man. So we just start with the usuals. And we'll have a blue square. Blue. Sorry, you don't do that. You say Vic 3. Is there any use of saying Vic 3 safe? Well, it's useful. Say 1.0 RGB. That's 0.0, comma 0.0, comma 1.0. So we have a blue this thing. Now, Minesweeper, Minesweeper. To do a Minesweeper game, I think a 5 by 5 grid would be sufficient enough. 5 by 5 is how many? 25. Yeah, 5 by 5 is sufficient enough. UV going to multiply UV by 5. We're going to save it. We're going to create a vec. So I'm going to call it uh, size UV times 5. Then we're going to what we're going to do now? Wait, what's my calculator? 5 times 1 is 5. So yeah, it's going to give us a perfect 5 by 5 grid. So we just need to now draw the grid. So I don't know. I just drew the grid. But if I tell you that I'm still confused on how to draw the grid, you won't believe me. Oh my gosh. So I think we can just do this and say um floats read equals to uh max. This time I think it's safe enough, like it's small enough for us to do that. Step say size comma 0.09. I'm going to just do it again. Step comma step size 0.09. Then we're going to mix read. I'm going to create a vec form. And here's going to be so today I'm going to try and learn how to do glue. I think that's what we're going to learn today because like we're doing shader. It's not actually we're not actually learning algorithmic maths. It's good to know, but that's what we're learning. So let's actually do our first shader. Okay, so um, we have our 5 by 5 box. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yes, 5. Okay, so now we want to actually make some safe and make some unsafe. So we're going to create another uniform, and this uniform is going to be um, it's going to be yeah, let's call it a float, and this float value is going to be the seed for the randomness, which we're going to generate within the shader. But I don't think because I don't think I can pass in a matrix larger than um, a 4 by 4. Let me check. Can I have an input math larger than 4 math in. Oh, use array of a vector. Best for arbitrary data set. If you need a large square matrix, I want to create a five by five matrix in GT script. Oh, so I'm going to create a button. I'm just going to come here, to the create um, a this button. So I'm just going to put the button here. I'm going to go to manage doc. See, button pressed. Connect. Must it be like this? President. Array is one thing I've never worked with in shaders. I need to get myself familiar with arrays. I think this is a good chance. Mhm. No, 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 no. Regardless of whatever it is, the cell color should be blue. Then now we need to translate. We need a way to translate mass position to UV coordinates. Okay. So let's say our mouse is on this square. The location is the square root of 0.363 square times 0.318 square. we need to relate cell and we need to relate cell and mouse position. Now, this mouse position have already been normalized, but it has not been clamped. So let me just clamp it up here. Wait, no, no. Why on earth would I do the length? The length does not give me any idea of the position. Instead, I think we can get some inspiration from that glowing position. Wait, we have our mass coordinate, which our mass coordinate is equal to our UV coordinate unscaled. So that means if we clamp our mass coordinate, all we need to do is multiply our mass coordinate by 5. Our mass coordinate is now equal to our UV coordinates. So now that our mass coordinate is now equals to our UV coordinates, we now need to work on indexing because let's see. Um let's see. I have blue in dot shader. R0, G0, B0, 1, and I want it to glow. How do I achieve this? Okay, so we'll multiply by glow intensity. Let's see. Okay, we'll multiply by glow intensity of like about 5. All right. How do I do that? It's not just coming to my head at all. It's not just coming to my head. Or no? How do I say at mouse pause? Wait, what's that? You're an idiot. If this my glue. This should work now. Why is it not working? Actually, it's not UV dot mouse. There are two reasons why that statement is just stupid. First and foremost, UV dot mouse is just a single point. So if we have a single glowing point, I highly doubt that we can see it. Only if we were to increase the intensity and make the mouse invisible. Wait, okay. Let's do that. I'm seeing the code that I need to use right in front of me, but my brain just can't comprehend it. Okay. Yeah. It's not even if I'm supposed to calculate. I'm supposed to calculate the distance to mouse. Let's see how this looks first. I need a teacher. I have this. I have this. I'm doing this. That's the wrong variable on. Okay. Okay, we need help. Okay, this is gaslighting me at this moment. What's the difference between I'm an idiot? Now we just need to work on the value here. Hmm. I'm just staring right now. I don't even know what to do. We want it to grow by the size of one grid. You are always there for me, Almighty God. You are my only one. No matter what you say, I will praise the Lord. And miracle. Okay, it's not a smooth step that I need. Oh. I can't target a grid in the distance. I can't do anything. Can't do anything. And we have done this times without number. I'm not just learning. Oh, look at, I'm silly. Okay, so We're adding one. The cursor tracker is just a one value for. I tell you no, but my body keeps on telling you yes. Star by your lipstick gets me so out of play. Baby, here you go again, making me love you. Stuck in my head, let it all go. You stuck on my body like a tattoo. Yeah, I'm feeling stupid, stupid, falling right to you. Yeah, cross my heart, I hope to die. But I only stay with one more night. Yeah, I know I say it a million times. But I only stay with you one more night. Ooh. Try to tell you no about my heart. Keeps on telling you yeah. Try to tell you slow. Your lipstick gets me so out of bed. Waking up in the morning. Yeah. How come addition works? Oh, we be bubble man. Bubble, bubble, bubble. In the setting. Enable bloom in your scene. Godot cannot render glow effects without word environment node processing the bright preset. Add a word environment node to your scene in the inspector. Create word environment. Create. Okay. Click on open settings. Scroll to glow and click on check enable. Uh, But we can't really make Minesweeper. Oh. I didn't even think about it. To make Minesweeper, we'll have to keep memory, and that's something that you can't do with shader. Every write cleans up the, or every frame cleans up the previous memory. Okay, so UV. So we create our grid, we create our mounts, we do our column and row, then we calculate column and row to get mouse index. Then cell state is equals to 0. If index is less than or equals to 0 and index is greater than or equals to 0 or is less than 25, cell state equals, then we'll collect the cell state. Then we'll convert it. Then we'll say if cell state equals 1, we'll set if cell state equals so no. If cell state equals 0 is green. If cell state equals 1. So I don't need to change my Godot script. So after all the cracking my brain to do mix, to simplify that shit to mix, you just use if statement to do it. These are an if statement. So basically, we're going to use the trick that we used yesterday. I don't know how we implemented it, but I'm going to try and implement it. Basically, what the trick is that we'll use two viewports. One viewport to save as a texture, The other viewport will serve as the rendering viewport. And what we will just simply do is we'll save our data to one viewport. So in every call, we read the other viewport, we check um, um, what is the state of this stuff at this moment in time. What is the state? What is the state? What is the state? What is the state? Then we'll update the state. Then we'll save it in the texture. So I'm not going to be able to accomplish it, so I'm just going to use the. Man, I'm already tired for the day. My brain has deteriorated. Let's use two, one, texture. If we click, we change the state. before Gemini used to support Godot in their browser, but now they no longer support it. What kind of tool does not work in the editor? Oh, no, I can't use it in this stuff. Anati, 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 forget it. Why is he blank? I just have to do that off stream. I wanted to make a post just now, but I'll do that later. Do I even really want to even play chess right now? I'm traumatized yesterday. I'm really tired today. You are, you alone are my heart desire and I long to worship you. You alone are my strength and shield. To you alone I must be. You alone are my heart desire and I long to worship you. As the deep and the world song it you alone are my heart desire and I long to worship you. You alone are my strength and shield. To you alone I must be. You alone are my heart desire and I long to worship you. You are my strength. Oh gosh. Oh shit. Wait, that's just war by me. You are my strength, my shield. You. Ah, she then picks it up. Oh my god. I better just read that. Okay, no, it's not so clear. Has the okay, it's clear. He still has the move. You alone are my heart desire and I long to worship you. You alone are my strength, my shield. To you alone I must be. Ish. You are my desire. Ah, long to as the be desire to be. Oh, my strength. Ah, you. I'm sure it was more Kimmy. Why am I analyzing game that I lost? Well, that's also the game that I lost that I was also analyzing because it means that the games I didn't understand the most. But fuck that shit. My baby send me the place. I need you, my baby, me, you. I need you, my baby, me. Oh God. Jeremiah, 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 que sé, Jeremiah, Jeremiah, Jeremiah. Count your blessings, name them one by one. Count. God has done. Count your blessings, name them one by one, and it will surprise you what the Lord has. When you are discouraged, thinking all is lost. Mm, 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 mm. Count your many blessings, name them one by one, and it will surprise you what the Lord has. Count your blessings, name them one by one. Count your blessings, see what God has done. Count your blessings, name them one by one. Count your many blessings, see what God has. When you are discouraged, blessings, name them one by one, and it will surprise you what the Lord count your blessings, name them one by one. Count your Old Roger is dead and's gone to his grave. Who gone to his grave? They planted an apple tree over his head. Who over his head? The apple grew ripe and ready to fall. Hey, who are ready to fall? They came an old woman to pick them all up. Who are pick them all up? Old Roger is dead and has gone to his grave. Who gone to his grave? The apple grew ripe and ready to fall. Who ready to fall? They came an old woman to pick them all up. Who pick them down to give me dozens. But does it make my pawn structure safer? I think so. So I can take or I can push that pawn forward again to threaten the queen. But the queen just moves and he can literally move to a position. He can move to a position to threaten the bishop in the next move. You can even move to like spy the knights. Then I just move the knights and there's no threat there. The biggest issue is that most of our pieces are misplaced. Right now, I'm not ready to play at any edge of the box. Let's just close the position. I mean, I'm the only one with the knights, so a closed position is good for me. Gosh. And just as I said, I'm the only one with the knight that a closed position is good for me. I lose my knights. Oh shit, I could have stopped that. I just did not. Okay, let's get our queen active. I'm winning their bishop in the next move if you don't move their queen. Ah shit, how did I lose so many pawns? Guillaume, eh, Guillaume, Guillaume, de minayo. Oh shit! Okay, no, it's not that bad. Come on, the position is bad though. 2 points down. I need to swing though. How? But how? How do I swing though in this position? He will trade bishop now. Oh! I'm like, she just as well resign. I've lost. But how am I getting played this much? Am I so out of practice? Let's see if I can buy a draw. Actually, I can't even buy a draw. Ba-da-dum-bum. When the motivation. Okay. There's no need to play this anymore. They have been no need to play since I started losing those pawns. Ah, I'm going to drop out of 1200 instead of reaching 1300. Like, the heck? I need to work on my opening. I'm not sure there's any of these games that I'll be winning from the opening. I don't want to lose again. Come on, let's find something creative. Find a brilliant sacrifice or something. Like, all your game have been so boring of recent. He taught us that in this position, White should also be generally losing, but I don't see the win for myself. I shouldn't have done that. Now he's going to temple my bishop. Oh, he didn't do it. Sef. This is a quite complex position, though. What do I want to do? I want to win this pawn, which I can win in this move, or I can wait for, or I can try. Oh, they dancing their way, guy. Oh shit, I miscalculated. Oh god, I miscalculated again. How? What am I even doing? Like, I can actually even just pressure my. Oh god, what am I doing? At least we still have enough pieces on the board. I just can't afford any other trade. Next move is knight and rook here. Rook here, take, takes, take, takes, then take. I lose. I shouldn't have even made that trade. Why did I make that trade? Okay, wait. I have this move. I have this move. I don't have enough pieces. Rook swing. All right, I think. Ish. Not nearly enough pieces, but I'll go for it this time. Okay, wait. Let's see how it plays out. Take with the rook. It takes back with his rook. I shouldn't even be taking back at this point. Wait, this could. Nothing just works out for me when I'm playing this guy. Now I'm a queen down. Is he going to sack the knight? It doesn't have to. No, it doesn't have to. It can just play some few more moves and still win the position with this. Okay. I mean, if I don't go for it at this moment in time, there's nothing else I can do. He can just block within rook, and then there's no attack. He forced the rook trade. I don't know how I ended up here. Wait, what? Oh! Fuck! Bro, why does everything work out for you? I didn't have to take immediately. I could have pushed the pawn, attacked one of his other pawns or something. Yeah, I win my queen and lose the castling. And let me lose castling right. Oh shit, I've lost that pawn. I'm just playing poor chess. Like the poorest of the poor chess. I just hung that what do you call it? Stuff for him to capture. He just chose not to capture it. I'm a pawn. I'm just a pawn down. I haven't wrecked the whole position yet. Ah, he does not like rook or ability. You're not going to develop today. Oh, oh god, I should have started. I should have played it a bit different. Okay, so okay, no, can't read yet. Oh yeah, yeah, I'm infiltrating. I'm infiltrating. Good, good, good. Let's trade. Yama, yama, so I'm going to trade off the pieces without losing my own piece. I should be fine. So, and the only way I'm going to lose my piece is if I fall for a ninth trick. For a ninth trick. Or I get this knight stranded in enemy territory. The next move now is here to win this pawn. Hmm, that's a tricky move. But I simply can just go down. How is that not a blunder? I could have just have taken the pawn. Well, you can't defend it. Oh, you can defend it. You can't defend it. Okay, now I can check in with my king. Okay, wait. The next square you can jump to is a light square. So no, it's not going to check my king and fuck my rook. And then let's jump. Wait. Why would you do that? Even the game that I'm winning itself to find mate is problem. Go straight now. Um, I'm I'm running down in time. Oh, I'm really low in time. Oh shit, I'm out of time. I'm out of time.